Welcome friends. So we are learning about the engineering curves. In the previous session, we have learnt about construction of hyperbola curve using general method of construction. So we'll continue with the same method of construction and we'll see another case, another curve, that is parabola. So this is the problem statement wherein we have been asked to draw a straight line AB of any length and then mark a point F 65 mm from AB. So this straight line AB is the directrix and this 65 mm from directrix is nothing but the fixed point focus. So the focal length is given as 65 mm and then we have been asked to trace the path of a point P such that the ratio of its distance from the fixed point F to the straight line AB, which is directrix, is 3/2, 1 and 2/3. So in the previous case we have seen 3/2, which is nothing but greater than 1, which means the eccentricity is greater than 1, so the curve is hyperbola. Now the second case is eccentricity is equal to 1. So that means we need to draw parabola using general method of construction. So now let us move to the demonstration of general method of construction of parabola. So first I'll write down the given data. So I'm making use of mtext command. So we have been given the focal length CF as 65 mm and the eccentricity as 1. So when the eccentricity is 1, the curve will be parabola curve. So this is the given data. Now the procedure is exactly similar to that of the construction of hyperbola curve. So we'll start with that construction. The very first step is to draw the directrix, which is nothing but fixed straight line AB of any length. So we are drawing a straight vertical line of any length. So this is our directrix AB. Then to this line, we need to draw one more line which is perpendicular to it. So that will be the axis. So I'm going to the OSNAP features, making midpoint option on. And somewhere at the middle of this line, I'm starting the horizontal line which represents the axis. So the vertical line is the directrix, horizontal line is the axis, and on this axis line, we need to mark the focal length CF, which is 65 mm. So again, I'll make use of line command and I'll draw one line whose length is 65 mm. The next step is to divide this focal length CF into number of equal parts. How many parts? The number of parts are defined by the summation of numerator and denominator in the eccentricity ratio. So since the eccentricity is given as 1, E is equal to 1, it means it is 1/1. So 1 in the numerator, 1 in the denominator, and when we add it, it becomes 2. So for a parabola, we need to divide this CF length into 2 equal parts. So for that, we'll make use of divide command. Select the line. Enter the number of segments as 2. And you can see a point has been shown over here. So this indicates the line has been divided into 2 equal parts. The next step is from this point, which is nothing but the vertex, we need to draw a line which is perpendicular to the axis. So I'll make OSNAP feature node on, and from here I need to draw perpendicular line. The length of this line will be equal to its distance from focus. So since this has been divided into 2 equal parts, we know that the distance will be half of the focal length. So the focal length is 65 mm. So we have divided this into 2 parts, so it means 32.5. So we need to draw a vertical or a perpendicular line of 32.5 mm. So this is line AB, then the axis is CD. This is the F focus point. Then we have got the vertex. From vertex we have drawn a perpendicular. So wherever this perpendicular line stops, that is point B. So now we need to join this C point with B and extend it. So I'm making use of line command and joining this. Now what happens is, because the focal length is being divided into two equal parts, this angle will become 45 degrees. So that means the horizontal portion length and this vertical portion length in the triangle will be same. And this is something that we need to remember. What we have done in the case of hyperbola was, after drawing this vertical line towards the right side of vertex, we have drawn multiple perpendicular lines. And on these lines, we have measured this 1 dash distance, 2 dash distance, and used it for drawing of arcs. Now here also the same procedure we need to follow, but the point what I wanted to tell you is, we don't have to measure actually 1 dash, because the horizontal and vertical sides of these triangles are same because of the angle made. So what we will do now is, at this vertex we will draw a temporary line which we can offset it later. So I'm copying the directrix line and placing it at the vertex. Once we do this, towards the right side of vertex we need to draw multiple perpendicular lines. So we will make use of offset command, define the offset distance as 10, select this line, place it on the right side. So we'll do it for some 3 to 4 points. The problem statement says 5, but I'm just showing it for some 4 points. So after placing these lines, we need to remove this temporary line from the vertex. So in the earlier problem, what we did is, this slant line we extended further. So wherever this slant line was meeting with the perpendicular lines, there we were getting 1 dash, 2 dash, 3 dash, 4 dash, and so on. Later on, we were measuring this 1 dash distance, 2 dash distance, and so on. Now we are not going to do that, because we have seen in this triangle that this vertical side and the horizontal side of this triangle are basically same. If you want to cross check, we'll go with the dim linear command. Check this value, this is 32.5. Similarly, I'm checking this horizontal one. So the horizontal and vertical sides both are of same dimension, and that is what I'm trying to tell you. So if you continue with this slant line, if you extend this slant line, then we'll have this as the horizontal length and this as the vertical length. Because of the angle 45 degrees, these values will remain same. So we don't have to practically extend this line and go on measuring. So I know that up to the midpoint it is 32.5 mm, and then beyond that I have made use of steps of 10 mm. So the first line will be at 42.5 mm, then this is 52.5 mm, 62.5 mm, and 72.5 mm. That is how we are proceeding. So in order to locate the F, I'll make use of point command and place it at this location, so that we have the clarity where focus point is. Then what is the next step? We generally measure this 1 dash distance, take F as center, and we start drawing the arcs. Now here, as I already told you that we don't have to do that, because the horizontal and vertical sides are of same length. I'll directly measure this distance. So I'll just show you. So we are measuring the distance from C to 1. So this is 42.5 mm. Similarly, I'll show from C to 2, it will be 52.5 mm, because we have taken equal divisions. So up to this vertex we have the distance of 32.5 mm. Beyond that we have added 10 mm each. So the first one is 32. This is 42.5 mm, then the next one is the 52, then 62, and so on. So now we will go with the arc command, go with the center option, pick F as center, make ortho of type 42.5 and press tab key. Now draw an arc on the first line. Repeat the same procedure now. Arc command, center option, focus as center, type 52.5 and tab. Draw arc on the second line. Again arc command, center option, focus as center, type 62.5, press tab key, draw an arc on the third line. Similarly, arc command, center option, define focus as center, type 72.5, press tab and draw an arc on the fourth line. So once you have drawn these arcs, make use of the mirror command, select each one of the arcs. So we have selected 4 arcs, press enter, define the endpoints of the axis as the mirror line. It is asking erase the source object, so click on this no. So you can see we have got the points on the parabola curve. Now make use of spline command. See that the intersection OSNAP is on. Pick this point, then the next intersection point, the next intersection of the arc with the vertical line. Similarly next, then the vertex, next intersection point, and similarly the last one. Once we have selected all these points, you can click on end tangency and then move the mouse so as to see the perfect position of the curve. Wherever you feel like the curve is in good shape, simply click anywhere on the screen and you will get the parabola curve. Since parabola is our main answer, select this curve, right click, go to properties, change the color of it, increase the line weight. So I'm selecting 0.35 mm. So this is how we can construct the parabola curve. The next part is to draw the tangent and normal, and for that the given data is from focus F, we need to locate a point which is at a distance of 50 mm. So again make use of arc command, arc, center option, focus as the center because that is what is given in the problem statement, that the distance of the point is 50 mm from focus F. So type 50, press tab key and then draw an arc such that it cuts the parabola curve. So this position where the newly drawn arc is cutting the parabola curve is point P. At this point P, we would like to draw the tangent and normal. So join this point P with focus F. So now we have got this line PF. The next step is to this line PF, we need to draw a line which is perpendicular. And we have already seen how to do that in the case of hyperbola problem. So what I'm doing is I'm going back to the OSNAP features. I'm making all the OSNAP features off and making perpendicular as on because I want to have a perpendicular line. Then I'm typing line command, move the cursor over to this slant line PF and you can see the software is showing us the perpendicular symbol. Anywhere on this line, click and start drawing a line. Its length should be such that it should cut the directrix AB. As per the procedure, this line, this perpendicular line should be drawn from focus. So now what we'll do is, we'll move this line to the focus point. So make use of move command, select this line, press enter. It is asking to pick the base point. So for that, I'll make intersection on, and I'll pick this intersection point and place it at this focus F. So now we got a line which is perpendicular to this PF line and starting through focus F. This line is cutting directrix AB at one point, which is nothing but S. So join this S with the point P. P is nothing but the point at which we want to draw the tangent and normal. So make use of the line command, pick this S point and draw the line up to this point P arc. So this is the required tangent, but we need to draw it on the other side also. So make use of extend command. If you are not able to extend it, you can check the angle when you are drawing it. See, I am placing the cursor exactly at this point and I can see the angle is shown as 54 degrees. Once you have clicked on the point P, now we need to draw that tangent line on the other side also, that is the extension of it. So in case the extend doesn't work, so you just remember the angle. So angle is 54. So I'm maintaining that 54 degrees angle and I'm drawing another line. So this line is nothing but the required tangent. Now we need to draw the normal. The normal should be a line which is perpendicular to the tangent and it should pass through this point P. So apply the same logic as that of drawing the normal. So we need to draw a line which is perpendicular. So go with the line command, move the cursor on to this tangent line and anywhere you draw a line which is perpendicular to this. So we got a perpendicular line, but its position is not correct. So we need to move this line. So select the line, press enter, pick the intersection point as the base point and place it on point P. So what you are able to see is the normal, but it is a half normal. We need to draw it on the other side. So you can make use of extend command. So this line is the normal. So now normal and tangent also need to be made as thick and bold because that is what is the answer of the question asked. So select the tangent and normal, right click, go to properties, change the color, apply the line weight as 0.35 and now you can see the parabola curve, the tangent and the normal as being shown prominently. So I have not shown all the letters, the alphabets, the points P1, P2 because we have already seen how to mark them in this hyperbola problem. So you need to make use of the same process for indicating this vertical line as AB, which is directrix. Then this horizontal line is your axis, which we call it as CC. Then this point is the focus point. So you need to mark it as F. And this is the vertex point. And towards the right side of vertex, we mark a number of equidistant points. So this is point number 1, 2, 3 and 4. From this vertex, we draw a vertical line whose length is equal to this VF distance. So this is point B. So join C with B. And wherever we are getting the arcs on this line number 1, 2, 3, we call this as point P1, P2, P3 and P4. Similarly, downwards will be P1 dash, P2 dash, P3 dash and P4 dash. For drawing the tangent and normal from focus F, we are drawing an arc at a distance of 50 mm. So wherever the arc cuts the parabola, that is point P. We are joining P with F. We got this slant line, and from here we are drawing a line which is perpendicular to PF, and it should intersect directrix AB at a point S. So join this S with P and extend. So this is line ST, which we call it as tangent, and a line perpendicular to tangent ST and passing through point P is your required normal NM. So this is how we construct the parabola curve. I hope you have understood this, and I want you to solve the third problem on ellipse curve, where the eccentricity will be 2 by 3, that is less than 1. You need to follow the same process as that of these curves. You will have to draw the directrix, then axis, then mark the focal length, divide the focal length into number of equal parts. The number of equal parts will be summation of numerator and denominator. So in the case of eccentricity of ellipse curve, we have 2 by 3 value. So it means 2 plus 3 is 5. So you need to divide the focal length into 5 equal parts. Then identify the vertex V and follow the same procedure as that of hyperbola curve. You will be able to get the ellipse curve. The procedure for drawing tangent and normal is also same. So with this, we have come to the end of the conic section, the construction of conical curves, ellipse, parabola, and hyperbola using general method of construction. See you in the next session. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.